Hey guys, sorry I'm not here today. What I need you to do is just watch through this video and fill in your notes on multiplying and dividing rational functions, and then you'll do the homework at the end. So let me see if I can get this stuff off my screen. So sorry. All right, so you did the hardest part yesterday when we did the adding and subtracting. So today we're just going to be multiplying and dividing, and the hardest part here is factoring. So we still can't get away from factoring. But once you factor, anything that is exactly the same on the top will cancel with what's on the bottom. And that's what it says here. You're going to factor your numerator and denominator completely. You're going to take out a GCF. You're going to factor out that negative, again, if your first term is negative, making sure that the polynomial is in descending order. You'll cancel out the factors that are exactly the same, and then we simplify and reduce. So this first one, so that we didn't have to do so much factoring, I've already worked out the top one for you. We've already factored that top one for you. And now we're going to factor this bottom part. So what you need to do is think about what number. There is no GCF. So we're going to say, well, what numbers multiply together to give me a negative 10? What numbers multiply together to give me a negative 10 while adding to give me a negative 9? Right, so I can think about a negative 10, and my bigger number has to be negative. So a negative 10 and a positive 1, that would give you a negative 9. So when we factor that, we get a 2x squared minus a 9x minus 5. I'm going to replace this 9x with those two terms. So negative 10x plus 1x, bringing down my 2x squared and my negative 5. So remember, all we need to do now is factor by grouping. So the GCF of these two would be a 2x, and that would leave me, when we divide through by a 2x here, that would leave me with x, and when you divide by a 2x over here, it'd leave you with a negative 5. And over on this side, remember, we're supposed to still get that x minus 5. Well, that's what I already have, is an x minus 5. So I'm going to take out that positive 1. So my factors are 2x plus 1 and x minus 5. And I'm going to write that here, 2x plus 1, x minus 5. So I've replaced this with these factors. I've replaced that with those factors. I've replaced that with those factors. And one last one we're going to try to do now is a 6x squared minus 30x plus 24. I'm going to go ahead and work this problem out again. 6, 30, and 24. I can take a 6 out of all of those. So if I take a 6 out, I'm left with an x squared minus 5x plus 4. I'm going to ask myself what numbers multiply to give me 4 while adding to give me a negative 5. And that would mean that both signs would have to be the same. They'll both have to be negative. And that would give me this negative 1 and negative 4. Since this has a leading coefficient of 1, I can do the shortcut. So there's your GCF. Put an x in both, and then I'll put a minus 4 with a minus 1 and a minus 4 there. So I can replace, again, that what we had back up here. I can replace this with those factors 6 times x minus 1 times x minus 4. So when we multiply fractions, we want to multiply across the top and multiply across the bottom. But when we have these rational functions, if we can simplify first, it will make our answers a lot easier. So anything that's on the top, because this is being multiplied, that dot means multiplied, this means multiplied. Everything's being multiplied across the top. Everything is being multiplied across the bottom. So they're all what we call factors. So if there's anything that's the same on the top as on the bottom, we can cancel them. So I'm going to start with this 3. Does 3 divide evenly into, here's another number, 6? It does. So what I'm going to do is I'm going to cancel that 3. I'm going to say 3 goes into 3 one time, 3 goes into 6 2 times. I'm going to walk across my numerator so I don't lose anything. Is there an x minus 5 on the bottom? There is, so that would cancel out. Is there an x plus 2 on the bottom? Nope, so that's going to stay in my answer. Is there an x minus 4 on the bottom? There is. And is there a 2x plus 1 on the bottom? There is. So then I go back and say, what am I left with? So 1, gone, gone. So I've got a 1, that's gone, and an x plus 2. So I have an x plus 2 on the top. These are gone. Gone, gone. I have a 2 and an x minus 1. And so my final answer here is x plus 2 on the top and 2 times x minus 1 on the bottom. So we're just going to continue to do that for all these problems. So as you look at these, again, the hardest part is going to be the factoring part. So the multiplication part is fairly easy. In this one, you can factor out a 21x. So if you factor out a 21x, I'm going to be left with an x minus 1. And in the bottom, I can factor out an 18x. And I'm going to be left with an x minus 1 in the bottom. And then over here, this is 6 times x and 6 times x squared. So I can't really factor that out anymore unless you want to rewrite this as 6 times x, because that might be a little bit easier to cancel out the x above. So here we go. 21 and 18 and a 6. So I can divide 21 and 18 could both be divided by 3. That would leave me with a 7 here and a 6 down here. Okay, can't do anything else with that. Well then, I see an x minus 1 in the top. Oops, I see an x and an x in the top and in the bottom. I see an x minus 1 and an x minus 1. I see a 6x and a 6x. So I've walked across the top. Now let's see what I'm left with. I had a 7. The x, that's all gone. That's all gone. So I have a 7 left in the top. I have a 6 left in the bottom and an x. So 7 divided by 6x is going to be my answer. Okay, so again, we're going to factor these out, and this is going to leave me with, I'm just going to write them over here if that's okay. That's going to leave me with an x minus 4 and an x plus 1, and you can slow this down, slow the video down if you want to, or pause it and factor it and then see if you have factored correctly. But again, there's nothing new with the factoring. It's the same factoring that we've done since Math 1. So I'm left with numbers that multiply to give me a negative 4, added to give me a negative 3. So I got x minus 4, x plus 1. And then again, I did that with all of these. So to multiply, since everything's being multiplied across, if there's anything in the top that cancels out with anything in the bottom, I'm going to cancel them out. Gone. So it looks to me like I'm left with an x plus 2 in the top and an x plus 5 in the denominator. Now I cannot cancel that x with that x because that doesn't say x times 2. It's not a factor. That is one whole thing. That is some number plus 2. So do not cancel those x's out. Okay, and then number 4 here, again, if we just jump to the factors. So I have a 9 in the top, 9 in the bottom. X plus 4 in the top, x plus 4 in the bottom. There's no other 9. There's no other x by itself. So my answer here is going to be 9x left on the top, x minus 4 times x minus 5 left in the bottom. Oops, I'm crooked. Sorry. All right, y'all. So that's multiplying. And then we're going to now switch and start talking about dividing. And division is actually just like multiplication, but instead of dividing, we change the division to multiplication, and then whatever we were dividing by, we use the reciprocal. So you may have heard of keep, change, flip, but then we're going to do the exact same math that we just did. So This one is going to reduce down, and it's going to become a, let me see. Well, I would write this whole problem right here, right? 6x squared plus 9x minus 15 divided by 4x squared minus 4. But I'm going to change that division to multiplication, and then I'm going to flip this over as the reciprocal because I multiply by its reciprocal. Or you change flip if you've learned it that way. But we don't do division of fractions. We multiply by the reciprocal. So this is the same problem that we just did, 1 through 4. So we're going to factor. We can factor out a GCF. And then we can factor what we're left with. And again, I'm just writing down the factors. You can pause this and actually work through factoring on your own and then check your answers to make sure that you got them correct. But the new part of today's lesson is not the factoring part. It's the multiplying part. And now that we're dividing, we take the fraction, divide it by another fraction. We change from division to multiplication of its reciprocal. So we literally, what was on the bottom goes to the top, top goes to the bottom. And then it becomes the same problem that we've done. So there's nothing in the bottom here that will cancel out with a 3, but I do have a 2x plus 5 that cancels. I have an x minus 1 that cancels, a 2 that will go into a 4, so I left with a 1 here and a 2 down there. I am left with an x plus 3, but the x plus 1s cancel. So reading across the top, I'm left with a 3, gone, 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 x plus, notice I'm multiplying, so it's 3 times x plus 3. And then on the bottom, I have this 2 times that 5, which makes it a 10, and then an x minus 2. Okay, and if we look on the other side, same kinds of problems. We're just doing more division problems, and then we'll talk about the complex fractions at the bottom. So when you see one like number 6, this is really over 1. So I've got 49, 49x plus, I'm going to just go ahead and factor this while I've got it here. I can take a 7 out, so I'm left with a 7x plus 5 all over 1. I'm going to change that to multiplication, and then this 5x minus 5 is going to come to the top. I'm going to worry about factoring that in just a second because I don't want to confuse you. So I multiply by its reciprocal. So 7 times 7x plus 5 over 1 times, I can take a 5 out, and I'm going to be left with x minus 1. And on the bottom here, let's see, we need to multiply to get a negative 35 and add to get a negative 2. All right, so when we work that one out, we're going to get a 7x plus 5 and an x minus 1. And then, so the 7x plus 5s cancel out. There was no 7 on the bottom. I can't cancel that 7 with that 7, but it's a 7x plus 5 that cancels out. And then the x minus 1 will cancel out. Y'all, we're left with 5 times 7, 35 is your answer. All right, so x squared minus 8x plus 15, x squared minus x minus 6, change it to multiplication, flip it over. It's reciprocal, so top goes to the bottom, bottom goes to the top. And then we're going to factor all of those. Okay, so I'm going to come up here, and it's going to be an x minus 5 times x minus 3, x minus 3, x plus 2, x minus 2, x minus 4, and x plus 5, x minus 4. Again, all I'm doing is asking myself what numbers multiply to give me a negative 20 while adding to give me a positive 1. And since these were all 1s, I could do the shortcut with all of these. Okay, nothing cancels with that. The x minus 3s go away. Nothing cancels with that. The x minus 4s go away. So my answer will be x minus 5 times x minus 2 in the top, and x plus 2 and x plus 5 in the bottom. All right, so that's multiplying and dividing fractions. Complex fractions look terrible, y'all, but it's what we just did, right? A complex fraction is, instead of writing it horizontally, they're writing it vertically. So what I'm going to do, the first thing I'm going to do is change this to write it horizontally. So this is saying x plus 5 over x squared minus 16 divided by x squared minus 25 over x minus 4. And then I do the same thing that we just did. I change it to multiplication, and then I do the same thing that we did for the first few problems. So x plus 5 over x squared minus 16 times x minus 4 over x squared minus 25. You can see some perfect squares here. So this is going to become x plus 5. This is going to be the x plus 4, x minus 4. And then this is going to be the x plus 5, x minus 5. Numbers take the square root of both of them, and then with a plus and minus sign. Well, the x plus 5's cancel, the x minus 4's cancel. So if everything's gone in the top, you have to show that everything's gone. So it's a 1, because really when you are dividing anything by itself, it's a big old 1. So if this cancels and it's a 1, and that's a 1, 1 times 1 is 1. And then on the bottom, you do still have your, almost ran out of room, x plus 4 and x minus 5. If you have something other than, if something is left, you don't have to write the 1. But if everything cancels out, you have to write the 1. All right, and then last but not least, we're going to do the same thing. This is 35x squared plus 28x divided by 5x squared minus 3x minus 2. I'm going to say times, I'm shortcutting on you here, divided by this would be times, flip it, x squared plus 37x plus 14, and then the 5x plus 4. So when you work that out, you're going to get 7x, 5x plus 4, x minus 1, x plus 2, x plus 7, 5x plus 2, and 5x plus 4. So the things that are canceling, there was no x by itself, there was no 7 by itself, but I did have the 5x plus 4. I don't have an x plus 7. I do have a 5x plus 2. So my answer on the top is a 7 times an x plus 7. And on the bottom, I have an x minus 1. Okay, last thing to talk about here is just be very careful. If you see, sometimes you must switch the order and factor out a negative to make it match another factor. So if I see 25 minus 5x, that would be the same thing if I switched that order and had a negative 5x plus 25, because in that case, I could flip that out and I could get a negative 5 and an x minus 5. If you see something that has an x minus 4, and then you have 4 minus x, that is not the same thing. But what you could do is you could say, if you factored out a negative 1, that would give you a negative 4 here and a positive x here, negative 4 plus x. And this is what I'm talking about here. If you rewrite this as negative 1 and you flip those around, this is still positive, that is still negative, and then they cancel. So you notice that your answer is negative 1. So if you ever see something where it's a subtraction problem and they've just switched places, then your answer, you can cross them out and put a negative 1. All right, thanks. So I'm going to have you guys just work through the